Ever thought how you can kill the sun? As we all know, the sun is a big ball of fire. And the first thought about killing fire is by pouring water over it. Am I right? Yeah. So the question arises here is, how much water will it be required to kill the sun? Now that's interesting. Before that, make sure you have subscribed to the channel and press the bell icon for an instant updates. Let's suppose we want to kill the sun for whatever absurd reason it might be. We will still be facing a lot of questions before coming to the original question asked. Questions like, how would we deliver it to the sun? Will all that water make it to the sun? Wouldn't it evaporate before reaching the star? Whatever your plan is, be careful because trying to kill the sun would only make it hotter. Here's what might happen if we kill the sun and the possible ways how to do so. Before we talk about how things could go wrong, let's talk about where can we find such amount of water to put on the sun. I have some ideas for it. How about the universe's largest ice cube? Or maybe a gigantic fire hose connected from Earth? How about an entire planet of water tossed into the sun? From these options, we can easily scrap off the first option, as no gigantic ice cube is going to pass through our solar system anytime soon. So that leaves us with the rest two options. We can sacrifice every single drop of water present on Earth. This would, however, drain all our oceans and all our freshwater too. After that, we can build an extremely long fire hose and blast the water through it towards the sun at a really high speed. Would this work? Let's keep it aside for a while. Considering the third option can still be reasonable. We can try using a giant planet made of water, since using all our water would be unreasonable. We can save all our water on Earth if we can find an exoplanet that has abundant water. To our luck, we know where it is. 40 light years away, there is a planet discovered by scientists which is made of water and has an atmosphere made of steam. This planet is named GJ1214b, but to make things less complicated, we will call it the water planet. This planet has a diameter 2.7 times larger than that of our Earth's and weighs 7 times heavier. Also, it has a lot more water and a lot less rock compared to Earth. There is probably enough water on this planet to put out the sun forever. But extinguishing the sun is not that easy, even if we have the perfect planet at our disposal. If by any chance we are able to crash this water planet into our sun, the first problem is the water freezing in space. The same problem is with the giant fire hose if we supplied all of the Earth's water through it. Although the ice would continue shooting towards the sun, it would be vaporized instantly as it approached the sun's atmosphere. This water vapor would then break down into hydrogen and oxygen atoms. And that's when things would take a turn for the worse. You see, the sun is a giant ball of fire whose core is constantly fusing hydrogen atoms into helium. This fusion process gives off a large amount of energy in the form of heat and light. Presence of more hydrogen on the sun would be like adding gasoline to the fire. The sun would turn bluish-white and grow at least 6 times as big. This would create an extreme heat wave across our planet and others in the solar system. Although we wouldn't be engulfed by the sun, but the consequences will be catastrophic if such a thing were to happen. The sun isn't burning because it's on fire and undergoing combustion. The sun is burning because it's currently fusing 2 atoms of hydrogen into 1 atom of helium. It's not a temperature thing, it's a gravity thing. The sun is just so gosh darn big the bits on the outside are pushing the bits on the inside together so hard they smoosh into bigger atoms, and that releases a lot of energy. No matter how much water you poured on the sun, it would continue to fuse hydrogen into helium due to the sheer mass of itself. All you're doing is adding more mass and more hydrogen. Adding water is just going to make the sun bigger and burn longer. If you add enough water, it's going to get bigger. The biggest star we know of, Canis Majoris, is about 14-20 times bigger than the sun, and it's probably still somewhat fusing hydrogen into helium in its outer shell. So that means that the sun is going to continue to fuse and throw off the heat while it bloats up. So let's skip the idea of killing our sun for now, because that would only make the sun grow angrier. Now, let's talk about 6 interesting facts about the sun. Number 1. Light from the sun takes approximately 8 minutes to reach the Earth. Travel speed of the light is 186,282 miles per second. So now, you can imagine how far is the sun. Number 2. Watching the sunset and rise at least 2 to 3 times per week can fight off depression and help you live longer. Number 3. 1/3 of the human population sneezes when they look at the sun. It is called a photic sneeze reflex, a genetic quirk that remains unexplained by the science, despite the fact the greatest people of the world were intrigued by this phenomenon. Number 4. If the sun was scaled down to the size of a white blood cell, the Milky Way would be the size of the continental United States. Number 5. The sun is actually a greenish-blue color, but Earth's atmosphere scatters certain color wavelengths, making it look yellow. Number 6. If you were able to fold a piece of paper 50 times, its thickness would exceed the distance from here to the sun. Fold it more than 8 times? Impossible. That's what you'd probably say. Okay, it does not seem to be true. Up to date, the record is 12, but the 12-fold piece of paper was not even higher than an ordinary table. How could 30 folds be equal to a distance to an object in space? In fact, we are reflecting this way just because our brains typically think linearly, not exponentially. So guys, that's it for today. Hope you enjoyed the video. See you tomorrow. Before that, make sure you have subscribed to the channel and press the bell icon for an instant update of our videos.